questions for any of the speakers? You got a microphone?
Tom, how you doing? Good talk.
Thank you.
I have a question about your last slide. You had you showed the distribution of the trapped OH as a function of latitude, and I noticed you had times on there. It was fascinating. At the end, you had times of like a fraction of a second to 10 to the 5 seconds for that kind of buildup. Would that imply that your model would also suggest that there's a diurnal aspect to this as well? I mean, would you see it in solar zenith angle as opposed to just latitude?
Yeah, so, is this on? And after listening to Dana's talk, and we'll have to look at this and see if there's a diurnal variation. I'm not sure of that, but we should look at this and see.
The times look like they would.
Yeah, yeah, and you mentioned this to me before, and you're right. I think we should look at this and see carefully. There is one thing that's implicit in our model, and that is that what we're seeing move around is not water; it's OH. But with an impact event, in what Dana was talking about, you can get a little bit of water, and that's going to move and leave, and then come back and move and leave. So there might be a little bit of that in there too.
Okay.
Any questions from the panelists?
I have one for Jeff, actually.
Hi, Sarah Kreitz, JAXA. I wondered if Shwai could just talk a little bit about the potential correlations between your water ice detections with spectroscopy and other data sets. For example, neutrons. I don't remember if you showed that on your slides, but you did have those like grouped, it seemed like your water ice detections were clustered in certain locations. Do those correlate with where we have high neutron measurements?
Yeah, I do the comparison like just myself because I do not have the full resolution of the neutron data. I just gathered the data from some paper. The locations all show strong epithermal neutron suppression. But I have to say, the neutron, the footprint is way larger, bigger than the M-cube footprint, so the suppression area is larger. And also not all suppression, epithermal neutron suppression regions show as feature. That could be because we don't have enough good quality M-cube data at those regions because that's maybe too dark.
Or the neutrons are also sensitive to potentially subsurface ice too, right? So
yes.
maybe,
Yeah, we had a discussion yesterday. It could be the ice is very fine particles mixed intermediately with regolith, so it could be thick. We cannot tell because M-cube only sends maybe top, at most top millimeter.
Thanks.
A question for Ted about Nervous. So you have those two kind of parameters that you're monitoring as it's drilling. Is there any autonomy involved in selecting kind of at what point in that drilling process to actually take a sample to the more in-depth analysis, or is that a human-in-the-loop process where you look at the results and then would make that decision?
Currently, it's a human-in-the-loop. What we're doing is we're using the prospecting instruments, Nervous and the neutron spectrometer, to say this looks like a hot spot. Nervous, we're always looking down where that drill is going to intersect the surface, or more specifically where the cuttings will be put out. So each 10 centimeters we can say this doesn't look promising, or it does look promising, but it's really a real-time, near real-time decision and discussion about, yeah, let's take that next step and deliver the next 10 centimeters to a crucible, heat it, feed it into the mass spec and GC.
Thank you.
Can I ask one?
Jeff. So your work was focusing on recent and ongoing stuff, but what about way back in lunar history? Could internal volatiles have been a major source for, ancient deposits? Like, I'm thinking of Matt Siegler's Polar Wander work.
Absolutely. Draw attention again to, there's an abstract by, it's delivery of, magmas deliver it. And during Mare volcanism, there was so much coming out. There's a paper by Deborah Needham and David Kring, an abstract last year, and it was the talk given. Copious amounts come out that has produced a temporary, you call it an atmosphere, right? And that can last for some millions of years during that time, and may come and go depending on the particular volume of eruptive materials. So I think that mechanism really matters. But so if we had the right amount of young magmatism, and there's debate about whether it's young or not, or how young it is, possibly there could be a pulse that might equal the amount of volatiles now in the poles. I mean, conceivably. So it may be a source by that mechanism. But that really does need to be looked into and integrated with how good the record is of relatively recent volcanism. The early, when the Maria were going off, especially all these pyroclastic eruptions, a large amount of volatiles were put into the atmosphere and ended up somewhere. And there must have been some cold trap somewhere. And I don't know if you looked into where.
She has.
Oh.
Well, yeah, I mean, we looked at the Schrodinger thing. So, I mean, things that are released close to the PSRs are more likely to get trapped, so that helps.
Question for Dana. The narrow angle camera is spotting fresh craters from meteor impact. Is there any value to adding a fresh crater to, let's say, a rover mission in terms of seeing evidence for volatiles? How long would you expect the volatiles to hang around, and if you had an impact that was fresh near a permanently shadowed region, what would you look for?
So you have a fresh impact into the permanently shadowed regions, into a ice-rich area. The impact is going to be pretty hot, and so what happens is that you get a large fraction of the vaporized material actually exceeds the escape velocity, so it's only going to be there for one hop. It's not ever going to come back to the moon. So something orbiting that's able to make many passes and just happen to be at the right place at the right time may be a better way to catch one of these things happening. If you are, on a lander, it's got to be pretty close in order to detect the plume. So, but it is certainly trying to catch one of these events happening would be a really good way to understand exactly what or how much volatiles are involved and the energies and all that.
Dana, you've been thinking about these lunar volatiles moving around for quite a long time. Have you ever considered the idea of trying to harvest some of this material?
Yeah, actually, and it's not my idea. A number of people have thought of that. If you have some migrating population that collects at the dawn terminator, that's you could put some sort of collection device down that's going to collect these.
Can I have a question? Oh, go ahead.
Oh, you go on.
Can I have a question for Tom? So in your in one of your slides showing the latitudinal variation, so I saw two drop very close to the pole. Is that true, or is some modeling issue?
Yeah, so that's a mathematical issue, I would argue. You know, where it just falls off right on the edges.
Yeah.
Yeah, I would say that's in the math. That's not intrinsic in the model.
Okay.
Now that I have the microphone, I'm going to sneak in a quick question, actually. So, and this may be, it's to Dana and Amanda. So I'm very curious about the diurnal variation, and trying to answer Bill's question, the diurnal variation of the UV. So did I understand that that was sort of, you had a change in the UV flux on the diurnal variation, on a diurnal basis that seemed to map the observation of the OH, or not? Is that right?
Yeah.
Because that, yeah.
Yeah, I mean, Amanda's doing the analysis of this, so you may want to jump in. But there is a latitudinal distribution. There is a local time distribution. There is an effect of the composition. There's a difference between the Mare and the Highland, which seems to suggest that the absorption properties are important. What's really interesting, I think, about what Amanda's work is that she's looked at times when the moon's in the magnetotail versus times when the moon is not, and there doesn't seem to be any difference, which means that the immediate flux of the solar wind isn't affecting the amount of hydration on the moon.
So Tom, I'll just jump in because it's not the UV flux that's changing, it's the reflectance, the shape of the reflectance that we're measuring.
Yeah, but the absorption is there, right? So this matches actually our model, because the thing that's breaking up the OH is a photon. And so if I have a modulation, or I have a diurnal variation in the absorption, then that's self-consistent.
Okay, well, maybe we can talk more about it a little bit later. I'm not absorbing what you're saying.
Okay, that's fine. So that's what I'm saying, is the lunar material is absorbing the light, and if there's a diurnal variation of it, then that could lead to the removal of the OH with time.
Okay.
Can I say something? This is not related to today's talk, but we do see diurnal variation with MCAPE data. And also the diurnal variation kind of like depend on temperature. So we don't see strong diurnal variation at a latitude less than around 25 degree. And beyond the 60 degree, we also do not see obvious diurnal variation. It shows like kind of a temperature dependence.
Jeff, one thing I wanted to mention is I think you had 10 to the 13 kilograms per year for solar wind. I think it's more like 10 to the 5. And you got it out of
Yeah, the crater.
well, the thing is, I just wonder if it's 10 to the 5, it actually makes your mechanism more believable or doable.
Yeah, it certainly does. And it's possible that I just took the flux per second per square centimeter and then start multiplying it up. But no, but there's the danger in all these things I did is that sometimes you forget Avogadro's number and you're off by a factor of 10 to the 23rd, and that is beyond even my error bar. So it could be, it's one of those wacky things I must have done in just scaling it up. Oh, and I made it from H to H2O, which is a factor of 10, right?
Yeah.
So.
I wanted to make the same comment. It looked like Dana's was showing 0.2 grams per second from LADI or 0.02 grams per second.
0.02.
So when I did these numbers quickly with my calculator, it was like 2,000 kilograms per year, which is entirely comparable to this calculation. So of course, yeah, it would be, you were saying that these 2,000 kilograms per year were over five quakes, Jeff?
Yeah. Per year, assuming 5 quakes, which is sort of what was observed during the follow-up. I didn't mention is the shallow moonquakes that are confined to the crust, then they are fairly strong in this magnitude 5 range.
And your number, Dana, was episodic or continuous?
That was the the continuous rate. So, yeah, his would be if
Well-
Laddie was there during a moonquake and there was a large release of water, then it would have brought all the density in the exosphere should have gone up, which could have happened. And
I mean, they
Laddie
look like the
could've-
same order
yeah,
of
but I don't know
magnitude
when
in
they
5
are.
events over 5 months. You have a finer chance
Yeah,
of seeing one.
yeah, we
Uh,
could have been there for one.
Yeah.
The numbers were not as off as you presented them.
I was not as off as I thought.
Okay, well, if there's no further questions, let's thank the speakers again. And I believe it's lunchtime.
So I'm a little confused when you say water. Is that OH or, what do you know? What it is?